So let's take a look here. So here we create a vector called teams, which is numeric. This is information about wins, losses for the National League East. So we say what do teams look like? Well, there it is. Philadelphia, New York Mets, Florida, somebody, Atlanta Braves, Washington Nationals, or Senators maybe. I don't know. Okay, so now we create a column wins, column of losses. And now we're going to bind them up. So now we bind up these three vectors, teams, wins, losses, into National League East, and then take a look at what we created. And so now it's a data frame. Note it added what are actually row names. They look like numbers. They default to character numbers. If you don't have names, it demands data frames, require that you have names for both the rows and the columns, or it'll give it them. Also, data frames, when you input a character vector, remember teams was character, and teams still is character. If we look at teams, character data will always print out with quote marks. This is one of the little things that really was a brilliant move, or a well thought out characteristic of R by the developers, and no doubt it was in the S language as well. They endowed it with characteristics such that whenever you display either an element or a structure, you don't have to ask what it is. You don't have to be issuing these commands about type of and mode, and well, mode you do sometimes, but certainly not for the structure or for the basic type. R is designed so that everything prints in a unique way to tell you what it is. Now, note though that when we show it as a frame, when we take that numeric or that character vector, Philadelphia, New York, and we express it as a data frame, the quotes are gone. Data frames will take your character vectors and will coerce them into factors. We'll make them a factor, at least as far as showing you the structure. And we'll talk more about that later. So a data frame is not a matrix. A data frame is two-dimensional. It has rows and columns like a matrix. And like a matrix, a data frame, the rows must be of equal length to each other, and the columns must be of equal length. You can't have one column longer than another like you can with a list. But a data frame is a list. A data frame is a type of list. It's a modified list. So they do share list characteristics. One of them is the way you refer to elements or columns in a data frame is name of the data frame, $, name of the column. And we'll talk more about this. You can refer to components in a list this way as well. We didn't do it, but you can. Now, the columns in a data frame are components. Think of them as components because they are. So if we say, what's this? What's in least NL East, $, prints it out. If we say NL East, we want to see, let's go back and show the whole thing. Here's our data frame. Note in the second command here, we're referencing this column, but we're saying just show us the ones for which the teams has this value. Note equality as two equal signs, not one, because we used one equal sign as a assignment operator. The single equal sign, it's like Java. Java does the same thing. The single equal sign is an assignment. That it doesn't mean equals. If you want equality, you must remember to use two of them. And even though I've been using R for years and Java for not that long, I always forget to do this. Okay, so two equal to is equal. So, but note this last example. In this last example, we're doing something different. We're referencing this column, but we're referencing it by the values in a different column as a subscript. Here's a subscript which is referencing this column, but only for this one. So what gets returned when we do that is this value, but we're referencing it by the values of the teams. And this is where the power of subscripting comes from. Note that this is not a number. This does not evaluate to a number. This is a condition, and what it evaluates to is trues and falses. So more generally, inside subscripts here's subscripts. Remember we said the brackets were unique, and they are. We have an expression. This is an expression. That's what it is. You can put any expression you want in here. It can be a function, it can be an object, anything that will evaluate